In this example, we're going to solve a right triangle. Angle C is 90 degrees. We're also given that A equals 42 degrees and side C equals 17.2 feet. When we solve a right triangle, we want to find all missing angles and side lengths. First, we can start by constructing a diagram to show triangle ABC. So remember that the right angle is angle C, and then the other angles are angle A and angle B. Next, label what we're given. So inside of angle A, I have 42 degrees, and side C is 17.2 feet. Side C is across or opposite from angle C. So the lowercase sides will always be directly across from the capital angles. So side C, which is the hypotenuse, is 17.2 feet. So my goal is to figure out angle B, side B, which is across from angle B, and side A, which is across from angle A. So first I'm going to solve for angle B because it's the third angle in the triangle, and I don't have to do any trigonometry to solve for a missing angle if I know the other two. So angle A plus angle B plus angle C in any triangle will always add up to 180 degrees. So right now I know that angle A is 42 degrees. I don't know angle B, but I do know that angle C is 90 degrees. So if I have find the sum of 42 plus 90, I get 132 degrees. And so to solve for angle B, I just need to subtract that sum from 180 to figure out the missing angle. So 180 minus 132 gives me a measure of 48 degrees for angle B. So you can really do this in any order that you want to, but if you know two angles, the third one is an easy step to go with. So now that leaves me with the other two sides. And we have a theorem for right triangles called the Pythagorean Theorem, but that's limited because it only works if you know two of the sides and you need to know the third. In this diagram, I do not know two sides, but I just know one. So I'm going to use trigonometry to find one of these missing sides. So I'm going to do this one at a time. And you can come from either angle A or angle B. So choose an angle that you know that's not the right angle. So I'm going to go with angle A. And then mark the sides coming from the perspective of angle A. So coming from the perspective of angle A, side A is opposite that angle. So I'm going to label opposite on side A. Side B is adjacent to the angle, it's touching it. And side C is the diagonal, it's the hypotenuse. You actually have two adjacent sides to the angle, but one of them will always be the hypotenuse. So now that I have labeled the three sides coming from the perspective of angle A, then I can set up Sohcahtoa. And let's go ahead and pick one of the sides to solve for. First, I'm going to find side A. Now, side A is opposite the angle, and then I need to pick another side in the triangle that I do know, and I do know side C, which is the hypotenuse. So that's why labeling the sides is important. So in this trig ratio, I have coming from angle A, opposite hypotenuse, and that's going to use the sine ratio. Sine of an angle is opposite over hypotenuse. So set up your trig ratio. Sine of your angle, so the degrees always goes next to the trig word, so sine of 42 degrees, equals fraction, and we do opposite side over hypotenuse. So I have side A over 17.2. Now in this equation, you're trying to solve for A, and we're going to use algebra. So right now it says A divided by 17.2. Well, the opposite operation of division is multiplication. So I'm going to multiply both sides of this equation by 17.2. On the right-hand side, when you multiply and divide by the same number, those cancel out, so I now have 17.2 times sine of 42 degrees is equal to A, and now I'm ready to enter this in my calculator. So you'll need to figure out how your calculator works with trig functions. Most calculators let you type it in order from left to right. So I would type it in exactly as I see this, 17.2, and you can hit times sine 42 equals, and you'll get A is approximately 11.5 feet if you round to the nearest tenth. Some calculators are backwards entry calculators, and so with those types of calculators, you have to type the angle first, and so you would do 42 sine times 17.2 and then hit equals at the end. So now that I know side A, I need to know side B, and then I have solved the triangle. So remember, side B was marked as adjacent to angle A, and then I can use the hypotenuse again. So I have adjacent hypotenuse. That's going to be cosine of the angle. So I set up the trig ratio. Cosine of angle A, so cosine of 42 degrees, equals fraction. Adjacent side over hypotenuse. So I'm going to have B over 17.2. To solve this equation for B, we multiply both sides by 17.2. So I get 17.2 times cosine of 42 degrees is equal to B. And then when I enter that in the calculator, I get B is approximately 12.8 feet. Now I want to point out that once you know side A, you can also use the Pythagorean theorem if you want to. So as an alternative, the Pythagorean theorem says legs squared plus legs squared equals hypotenuse squared. The legs come off of the right angle. So in this figure, my legs are side A and side B. So I could set up the equation 11.5 squared plus B squared equals 17.2 squared. Next, use your x squared key on your calculator to solve these numbers that are squared and write those down. So I get 11.5 squared is 132.25 and 17.2 squared is 295.84. Then we want to get b squared alone, so we subtract the number 132.25 from both sides of the equation. So this gives us the value 163.59. And your final step is to square root both sides to get b. So if I hit second x squared, I'm going to get the square root function on my calculator. And the square root of 163.59 is approximately 12.79, so you could say 12.8 since they want you to round to the nearest tenth. So notice that is the same value that we got when we used the trig ratio, so you do have a couple of choices.